Today we are going to discuss about the halogenation of alkenes. In the last presentation, we have seen that it can undergo hydrogenation to give rise to alkenes. Addition of hydrogens across the carbon-carbon double bond. It gives rise to alkanes, and this reaction occurs in the presence of the catalyst. The catalyst which is used is platinum, palladium or nickel in the finely divided form. The halogenation of alkenes is also another electrophilic addition reaction which an alkene can undergo. As we know that halogens are electron deficient system and alkenes are pi excessive system, that is electron excessive system. And as this is halogens are deficient, alkenes are electron rich, the reaction between these two are possible, and this leads to halogenation of alkenes. When we halogenate the alkenes, the halogens adds across the carbon double bond, and it gives rise to 1 comma 2 dihaloalkane, that is vicinal dihalides. The product formed is vicinal dihalides. I take alkene. The simplest example for alkene is ethene. It reacts with any halogen, preferably the bromine, in the presence of a non-polar solvent like carbon tetrachloride or chloroform, and when I heat it, it gives rise to 1 comma 2 dibromoethane. The bromine which is added are in the two different phases. One bromine adds above the plane of the carbon-carbon double bond. Another bromine adds below the plane of the carbon-carbon double bond. And this gives anti-product. And this is anti-addition reaction. Why it undergo anti-addition reaction? What is the mechanism it follows? Let us look into it. When this mechanism was explored, how this gets added up across the carbon-carbon double bond, why it follows anti-addition, mechanism exploration showed that an intermediate is formed. The intermediate formed in the reaction is halonium ion. Now, let us look into how this halonium ion is formed. Alkene, I take ethene, bromine or any halogen. The electrons are shared equally and they are not polarized. But and it is non-polar. But in the presence of an electron-rich molecule like alkene, it induces polarization in the bromine. It is something like we see a police officer when we two friends are going together. What I do? I will stand behind or I'll turn my face. And because the two electron rich atoms repel, the electrons in the bromine repels away to the other atom, making one of the atom delta negative, that is electron rich, and another delta positive, that is electron deficient. This is called as induced polarization. As such, bromine is non-polar in nature. But in the presence of a nucleophile like alkene, it induced polarization in this bromine molecules. That is called as induced polarization. And as it has a positive center, this positive center of the bromine acts as an electrophile as it is electron deficient. In the presence of an electrophile, there is the disturbance in the alkene molecule, that is ethene, and it induces electromeric effect. And we know that this electromeric effect is a temporary polarization that occurs across carbon-carbon double bond in the presence of an electrophile like Br plus. That's why the pi electrons moves towards one carbon and it gives rise to electron richness. The another carbon which has lost the electrons become electron deficient, which is represented as positive center. This I said as Mahesh Babu effect. And because of this electron richness of this carbon, this electron rich carbon electrons are shared with the electron deficient bromine, and as to maintain its valency, bromide ion gets removed and we get Br minus. Along with that, bromine gets added across this carbon double bond. As these excess electrons are shared with bromine, the bromine becomes electron rich. The carbon which is adjacent to this carbon where bromine is attached is electron deficient. This is electron rich and electron deficient, and both are adjacent to each other. It is like a girl and a boy which are adjacent to each other. The attraction occurs. This is excess in electrons, this is electron deficient. These excess electrons get shared onto this electron deficient carbon and it gives rise to bromonium ion. If there is chlorine, it gives chloronium ion. If it is iodine, iodonium ion. That's why in general we are named it as halonium ion. Then bromide Br minus, and this bromine is electronegative, right? And that's why this is pulling the electrons from this carbon and also from this carbon, and that's why it is having positive center and this is also positive center. The bromonium ion is polar, it has the positive center and the negative center, and it is an intermediate form, and intermediates are always unstable and it has to gain its stability. Hence, it reacts with bromide ion. This bromine is electron rich. This is also electron rich, that will repel. It do not attacks in the bromine side, but it attacks from the opposite side, away from this bromonium ion. It can attack on the opposite side, on the opposite face, like in case of hydrogenation, both the hydrogens added on the same face of the alkene. But here it is added on the opposite face of the alkene. There, when hydrogenation occurred, it gives rise to syn addition, as the hydrogens are added on the same face of the alkene. Here, it is added on the opposite face of the alkene. That's why it undergo anti-addition. The bromines, two bromines which are added, are on the opposite faces of the same alkene. That's why I get 1 2 dibromo ethane, that is vicinal dihalides. The halogens are on the two adjacent carbon. This is how the addition of a halogen across the carbon-carbon double bond to give anti-addition product. This anti-addition product occurs because the bromonium ion is formed. If at all it would have added on the same phase of the alkene, like hydrogen added on the same phase of the alkene, it would have given syn addition. The formation of this anti dibromoethane indicates that the intermediate formed is halonium ion. This is how the mechanism it follows. The bromonium ion is an intermediate. They are highly unstable. These bromonium ions cannot be isolated as they are highly unstable. These are transient species. They cannot be isolated. It is an intermediate between the starting material and the product. Product is more stable than the starting material. That's why reaction occurs. This intermediate is highly unstable. It has very high energy than that of the starting material or than that of the product. That's why it is highly unstable. The conversion of the starting material to the product occurs via intermediate. This intermediate which is formed is an halonium ion in case of halogenation of alkenes. How we say that halonium ion is formed? We should isolate this, but it is not isolable. And otherwise we have to entrap this and we have to analyze the structure of this intermediate, and from where we can say the halonium ion is an intermediate form. And in the next presentation we discuss with other addition reactions of alkenes. Till then, have a nice day. Thank you.